Warping and bending space-time? I know it sounds crazy, right? But it's actually true. That's what gravitational waves do. What exactly are gravitational waves, and what's Einstein's theory of gravitational waves? What are some mysteries that are still unsolved about gravitational waves? Well, in this episode, I want to be talking to Dr. Zoheyr Doctor. He studies black holes and gravitational waves and is an astrophysicist at Northwestern University and knows a lot about these gravitational waves and the crazy science behind it. Let's get right into this amazing and action-packed interview. Let's go. Hello.
Hey, how's it going?
Good. How about you?
Doing great. Yeah, happy Sunday.
Happy Sunday. So can you please introduce yourself to listeners?
Yeah, my name is Zoheyr Doctor, Dr. Zoheyr Doctor. So people call me Doctor sometimes. I'm a research assistant professor at Northwestern University where I study astrophysics.
Well, that's really cool. So how'd you get interested in science?
I think I was always interested in science and puzzles. Even from when I was young, I loved doing like little, like solving codes and other sort of puzzles or Legos, that kind of thing. But then when I got into high school, I started studying calculus my senior year of high school. And I absolutely loved calculus. And it was just an absolutely beautiful subject to me. And when I realized I loved it so much, I thought, when I go to college, I've got to learn more calculus. And I knew that one of the biggest applications of calculus was physics. So I started studying more physics in college. And once I started taking some classes, I just couldn't get enough of it. So I just kept studying more and more and reading Wikipedia articles late at night. And I got totally obsessed with physics.
Well, that's really cool. So went from reading Wikipedia articles to full-on studying black holes and astrophysics.
That's
That's
right.
a really interesting way to get interested in science, but that's really awesome. So, you study gravitational waves and black holes, right? Well, let's
Yeah,
get into that science because it's kind of mind-bending and really, really interesting. So let's get into it.
sure.
What are gravitational waves and how are they caused?
Yeah, that's a great question. And maybe before I answer the question about gravitational waves, I can step back just a little bit and tell you a little bit about the theory of gravity. So in the early 1900s and before that, our theory of gravity was based on Newton's conception of gravity. So in Newton's theory, you would basically have objects, and the distance between the objects and their mass would basically tell you how much force there was that attracted the two objects together. So sort of like in the background of my picture right now, I've got these two, let's say they're two stars, right? And
Mm-hmm.
the force between the two stars would just depend on the distance and the mass of the two stars. Now, there were some observations that could not quite explain. And so Einstein came along and he came up with this theory called relativity. And that was really more a theory about electromagnetism originally. But then he came up with a theory called general theory of relativity. And the general theory of relativity, that was a theory of space-time and the bending of space-time. And so Einstein's theory basically said that gravity was not forces between objects. It was actually the bending of space-time. And as space-time warps, objects move in straight lines in that warped space-time, but that looks as if things are bending.
Wow.
And so that's what causes, say, things to orbit each other or objects to have gravitational attraction to each other. So in this theory, there is the warping of space-time. And one of the things that Einstein found was that in the theory, you could get these small ripples that could travel like waves in space-time. And those are called gravitational waves. And those are created by mass and energy that is moving it's accelerating in a non-spherically symmetric way. So basically any sort of accelerating matter or energy would cause these gravitational waves, these ripples that would travel out across the universe.
Well, that's really
Really where
interesting.
they come from. Yeah.
So how are these gravitational waves that we're talking about now, how are they caused?
So they're really caused by any matter or energy that's moving in an asymmetric way, but they have a very, very, very minute effect, so small that it's basically imperceptible. But if you get some objects that are massive enough and accelerating enough, that can actually cause gravitational waves that are large enough that we can detect with very, very sensitive detectors.
Wow.
And so today we're able to detect gravitational waves both from black holes that are, say, 10 plus 10 to 100 times the mass of the sun, um, orbiting each other and colliding with each other. Also, neutron stars, which are sort of cousins of black holes. They're also able to ripple the fabric of space-time so much that we can actually detect that here on Earth. And then we've also detected gravitational waves that are at a much lower frequency. We don't know exactly where those come from, but we think that they could be caused by supermassive black holes on the order of millions to billions of times the mass of the sun, these black holes orbiting each other far out in the universe.
Wow. So the space time basically warps and ripples through the universe and it causes us to feel it like millions of light years away. How long does it
Exactly.
take for that gravitational wave to travel from, let's say, a black hole that's in another galaxy to us?
Yeah, well, if it's millions of light years away, then that's basically going to take, millions of years. So when we look at gravitational waves, we're actually able to probe the universe at times that are much earlier than now. And that's one of the coolest things about gravitational waves and about studying them. We can see very far into the past of the universe, try to understand what was the universe like a long, long time ago.
Wow, so you can basically use these as like a time machine kind of.
Totally. Absolutely.
That's so cool. So, what impacts do gravitational waves have on the universe?
Yeah, that's a good question. It's actually kind of ironic because they have very, very little effect.
Oh, wow.
So, for example, if we have two black holes that are colliding and they're, let's say, 10 times the mass of the sun, and they're, maybe a few million light years away, that's going to make an effect that's like changing the distance between here and the closest star by the width of a hair.
Oh,
So we're talking about very, very minute changes that you basically could never detect unless you have the most sensitive detectors. And it was only in the last 10 years that we've been able to detect these through both through incredibly sensitive detectors and through telescopes that are able to measure pulsars, these neutron stars across the galaxy, very, very accurately. But these gravitational waves have a very small effect. And that's why we can basically live our lives and never even notice that they're there.
yeah. So then, how do you detect these gravitational waves in your research?
Yeah, I'll talk about the way that I use and many other people I work with use. We have these detectors called interferometers. It's basically a system of lasers that go over very large distances, talking about a few kilometers. And these laser beams travel across these distances to mirrors. They're then reflected back. And as a gravitational wave comes in, it actually perturbs the distances that those laser beams traverse because they're warping space-time as the gravitational waves pass. And so we're able to measure those changes in the lengths of those laser beams. And that ultimately is how we can detect these gravitational waves.
Wow, that's a really cool way using lasers. That's a really cool technology. But you're saying that it can warp the lengths of the lasers or the time it takes. Does that mean it can warp us humans too? Does that mean I get taller every time a gravitational wave comes along?
Absolutely. That it is true that you would get a little bit taller, a little bit you could either get taller or you could also get wider. So you get stretched and squeezed. But again, the amount that happens is like one part in a billion, million that you're getting stretched and squeezed. So it's basically imperceptible.
What are some mysteries that you scientist detectives are still trying to solve about gravitational waves?
So I think the biggest mystery associated with gravitational waves is where do they come from? We think that a lot of gravitational waves come from either two black holes in an orbit, two neutron stars in an orbit, a neutron star and a black hole in an orbit, or two supermassive black holes in orbit. But we don't really have a good idea of how that comes to be in the first place. And I think that's one of the central mysteries. How do you ever get these black holes or neutron stars close enough so that they will actually collide with each other within the length of the universe, which is about 14 billion years? And so this is something that we're studying at Northwestern, and a really big mystery that I personally want to solve.
That's great. You're a scientist detective, so you'll solve it soon.
I hope so.
Yep. So this is really, really interesting, and how the gravitational waves are able to travel through the universe is just amazing. So, how did they travel such far distances without dissipating?
Yeah, part of it is because they have such a minute effect, right? So when a gravitational wave passes, it moves things so little that the energy from the gravitational wave is barely taken away. So that's how they're able to traverse very, very far distances, right? And this is sort of different from electromagnetic waves, right? Electromagnetic waves, lots of things can get in the way, like dust, for example, in our galaxy can obscure light, but we don't have to worry about that with gravitational waves. We can kind of see through everything.
Mm-hmm.
And so just to give one cool example, when a star explodes in a supernova, it's possible the star will explode in a way that's not very symmetric. And if that were to happen, and it were to happen in our galaxy, we could detect that with gravitational waves. It hasn't happened yet, but if it did, we would be able to detect it. And we would be able to see almost into the star in a way that we couldn't do with, say, electromagnetic telescopes.
Just kind of like an X-ray, but not really an X-ray because it's using gravitational waves to see inside of stars and galaxies.
Yeah, that's right.
Wow, that is some really, really cool science. And speaking of science, what advice do you have for kids who are interested in science? And especially like me, I'm also interested in astrophysics and space science. So what advice do you have?
Yeah, I think my number one piece of advice is just like follow what you enjoy. If you enjoy reading about space, there's so many books out there. There's so many like Wikipedia articles and YouTube videos and stuff to watch. So you should follow your interest. And then, of course, if you really want to study it in college, then that's also an option that's there after high school. If you work hard in high school, you can go to college, and many colleges will have astronomy classes, astrophysics classes. And so that's a good way to kind of get a very, what I would say, formal training. But, I think one of the beautiful things about astronomy and physics is that you don't need formal training to really enjoy it. There's lots of great resources out there just to enjoy the science. And a lot of my job is making it so that anybody can enjoy the wonderful world of astronomy and learn about the universe.
Well, that's some really great advice. Thank you so much for joining me today, Dr. Doctor. I really enjoyed it, and I learned so much in this interview, and hopefully I'll get to pursue some gravitational waves in the future as well. And I hope my listeners also learned a lot from this interview. Thank you so much.
Thanks, Akshay. It was great talking to you.
Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay Raman. Our theme song and additional music are by Chan Ramachandran. Special thanks to Dr. Zoheyr Doctor for accepting my interview invite. Dr. Doctor, I learned so much in this interview, and I had a great time. Thank you so much. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Also, do you have a science question that you want answered on a Spectacular Science episode and get a special shout out? Well, grab a grown up and head over to spectacularsci.com/contact. There you can find a contact form where you can send me your amazing science questions. I can't wait to read your amazing science questions and use them in upcoming episodes. Thank you so much. Also, don't forget to subscribe to this podcast wherever you're listening right now. It really encourages me, and you'll be up to date on all the new episodes. Subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.